Maxwell equations are a beautiful and compact system of equations that describes the behavior of electric field and the magnetic field. All modern electrical, electronic, magnetic, radio and power generation systems dance inside the compact model of Maxwell equations. These equations led Maxwell to predict an entirely new phenomenon, something undreamed before. You know what that? Electromagnetic waves that propagate through the space. From these equations led Maxwell to predict an entirely new phenomenon, something undreamed before. You know what? That is EM waves, electromagnetic waves that propagate through the space. From these equations, Maxwell derived the existing law of electricity and magnetisms. And Maxwell found a constant that is called a C, and it was the speed of propagation of the electromagnetic waves. Maxwell unified the law of electricity and magnetisms, created a mathematical basis for the fields, predicted electromagnetic radiations, explained the light, which had been an unsolved mystery for the hundreds of years. You know, there are total 4 equations called Maxwell equations. There are 4 equations that come together to form Maxwell equations. Number 1, Gauss law. It describes the electrical field. Number 2, Gauss law for magnetism. It describes the magnetic field and non-existence of the magnetic monopoles. Third, Faraday's law. Faraday law tells us to what extent a changing magnetic field creates an electrical field. Fourth one, last, Ampere's law. It shows to what extent current can be induced by a moving magnet generator, or that a magnetic field can be induced by a current. Magnetic field can be induced by a current. You know what's that? Motor, electromagnets. The basic equations of electromagnetisms, which are the collection of the Gauss law for electricity, Gauss law for magnetism, Faraday laws of electromagnetic induction, Ampere's law for currents in conductor, they are called Maxwell equations. Okay. But one thing you keep in mind, Maxwell discovered that electric and magnetic field are not independent. Okay? That is, electric and magnetic field are the two faces of the same coin. Let's come in first of all the Gauss law, which is very simple. Gauss law tells us about the divergence of the electrical field. is equals to 1 over epsilon naught times the charge enclosed by a body. What the divergence is, just look to the figure. That, something is, diverging out. What's diverging out? The electrical fields. We're moving away from the body, the length of the line, the gone shortening, the length is gone shortening because the length tells us about the magnitude of the electrical field. So, what's emerging out there is the electrical field or electrical flux. So it emerged from a finite region of the space. Finite region of space. With what? With the electrical charges. Okay. And that flux which has emerged out, it is proportional to the net charge in that region. Net charge means you take the algebraical sum. Some are the positive charges, some are the negative charges. You take the sum. Okay. And whatever the net charge divided by epsilon naught, thus becomes the divergence of the flux. Now, again, important, how these charges are distributed inside the region. That it is not important. Important is only what is the net charge inside the system. And proportional to that, the electrical flux it emerges out. Okay? Now I am coming to the Gauss law, the second Maxwell equation, the Gauss law for magnetisms. Now it is again the divergence. What's the divergence? Divergence of the magnetic field. But divergence of magnetic field is equals to, 0, no value. Why so? Because magnetic field always exists in loops. Because in case of magnetic field, there always exists a dipole, north pole and south pole together. In nature, you never find a single pole. That's the reason. Because dipole exists, so there are the loops of the magnetic fields. So if you take some region, okay, and if the magnetic field emerge out, whatever the intensity of the amount of the magnetic field emerge out, the same will, it enters in that region. The same amount of field it enters in that region. Emerging and entering, that amount, it is the same. So what is the net? So there is no net divergence. Because it exists, the field exists in the loops. So they do not diverge like the charges. And magnetic field, is having some rotation, loop behavior. And divergence of magnetic field will be the 0. And it states that, Gauss law of magnetism states that impossibility of creating a magnetic monopole. So there is no magnetic monopole in the nature. If you find that, you tell me, you can get a Nobel Prize for that. Okay, the net magnetic flux is 0 in any region, which is equivalent to the notation that there is no such thing as a fundamental magnetic charge generating the magnetic field. Okay, we can guess that if the monopole exists, if monopole were to exist, then what would be the form of the Gauss law for magnetism? The divergence of the magnetic field is equals to something mu naught, and instead of charge there will be some magnetic strength of that monopole. But monopole never exists. It's not existing in nature. So divergence of magnetic field is 0. Now I'm coming to the third law, Maxwell third law, very, very important, Faraday's law. Faraday law tells us about the curl of the electric field. The electric field is generated, the induced current is generated induced EMF is generated when the magnetic field changes with time, when the magnetic flux changes with time. And what's the relation or the equation of the magnetic field or magnetic flux changes with time? That the curly B by curly T. With negative sign mean, according to the Lenz's law, conservation of energy. Okay, that the magnetic field, whenever the magnetic flux is changes with respect to time, electric field, electric current, or EMF, induced EMF will be generated. Curl of electrical field. Okay. Here you are looking at the figure number 1. Here is a loop, and loop is connected with a galvanometer. There is a magnet. Magnet is stationary, and galvanometer is not showing any deflection. That means nothing is circulating in the coil. So what it mean? It means there is a magnet, there is a flux, there is a coil, but flux is not changing because the magnet is stationary. If the flux is not changing, flux is linked, but it's not changing, so there is no induced EMF, there is no induced current. Right. Now you take the, this is a coil. This is a coil. So this is a coil, and this is a magnet. You suppose that this is a magnet. When I'm bringing the magnet near the coil, okay, even it is moved inside, but it is not going to touch the coil. So if it is moved inside, galvanometer showing a deflection, and the pointer is towards the right hand side. And second, if I'm bringing it more speed, if it is bringing with more speed, then there will be more induced EMF. The pointer will show more deflection towards the right hand side. Then the magnitude of the induced EMF or the induced current produced is proportional to rate of change of magnetic flux, with what rate it is changing. Now third is, if I kept the magnet inside and it is held stationary, is not moving, again the pointer comes to the 0 point. That means induced EMF becomes 0 in that case. No induced EMF. Mean only the flux is not important. The change in flux is important. Okay. Now the next thing is, if I take out the magnet and it is moved away from coil. Now the figure 3rd. Again, the galvanometer shows a deflection of the pointers along the left-hand side. What does it mean? When it was it is moving towards, then the pointer towards right. When it is taking out, it is towards the left-hand side deflection. That means induced EMF changes its direction when the magnet is moved in, when magnet is moved towards or you take it away, then the direction of the induced EMF becomes reversed. Okay, that's again a very important law. That's the Lenz law, which is according to the conservation of energy. Mean induced EMF, or the energy is produced in the coil, because when you are bringing the magnet towards or taking it away, then coil opposes this, motion of the magnet. Coil is giving opposition to the motion of the magnet. When you are working against the opposition, that your work which is engaged, you are doing the work against the opposition, that work is converted into electrical energy. There's a negative sign in the 3rd equation. minus curly B by curly T is equals to curl of electric field. Curl of electric field means around it current is circulating in a closed path. Okay, induced EMF is produced. Now I'm coming the fourth law, the fourth equation. The fourth equation is mu naught J plus mu naught epsilon naught curly E by curly T is equals to curl of magnetic field. Now in this equation, there are two currents. Now one is the conduction current and the second is the displacement current. You know what's the conduction current? When there is a wire and electron drifting or moving in the wire, okay, when the charge is flowing, electrons are moving, then there is a conduction current. Because electron itself, they are moving. Or the charge is moving. Now you consider the second case, you are having a capacitor. One plate is positive, other is negative. Now there will be a field inside the capacitor, positive to negative. But that field is, if the field is constant, then there will be no current inside the capacitor. But if the electric field between the two plates, if it is varying, if the electric field which is existing between the two plates, it is varying, okay, what happens? There will be current in the space between the plate of the capacitor, that is called the displacement current, and that relation is curly E by curly T. Electrical field, electrical flux, it is changing with respect to time. Okay, so the displacement current is because of the electrical field is changing with respect to time. Conduction current because the charge is flowing. Now these two, maybe conduction current, maybe displaced current, they are responsible for generating a magnetic field. The curl of the magnetic field. Curl means like if you are having a straight current carrying conductor, the field like this one, the field will be produced around it, magnetic field, in a circular path. Like current is flowing upward, the field will be like this, and around it form. So this is a curl of the magnetic field. What's the reason of curl of magnetic field? There's a G, current density, current, or a second, that it may be displacement current is responsible for the magnetic field around the current carrying conductors. That's Ampere law. You call it Ampere circular law. Okay, that's the fourth Maxwell. These are four Maxwell equations. So combining these four equations, we have the analytical expressions of the electromagnetic waves expanding in vacuum or in a particular medium. You know that the EM waves, there exists an electric field, there exists a magnetic field, and they cannot, it's not possible to separate the electric and the magnetic fields, which are linked together. But like if the wave is going along this direction, the field may be along the y direction, electrical field may be along the y direction, varying along y direction. The magnetic field will vary along the z direction. The magnetic field will be in this plane, Electric field will be in this plane, variation of field, electric field will be in this plane, and the wave is propagating along the x direction. Along x, electric field along y, magnetic field along the z. So A and B remain perpendicular to each other. Okay. So how the EM wave is generated? Very simple. Maxwell equations. So Maxwell equations, that the propagation speed of the EM wave is equals to C is equals to 1 upon the root of mu naught and epsilon naught, which is the speed of light. So this is all about the Maxwell equations. They are very, very important. They are conceptual and they are very good for the EM waves So, if anything is not clear to you, please you write me in the comments box. Then I will then improve, or I will add something else if you want. Thank you very much.